But we don't want to rest with the efficiency gains just associated with new aircraft and new engines. Along with our star partners, we're challenging manufacturers to deliver a 30% fuel efficiency gain in the next generation of narrow-body jets, and crucially to bring that technology to market before the end of the next decade. There is an enormous prize for the manufacturer that can deliver against that challenge. But a lot is about enhancing our existing fleet. This year we revisited and approved an internal business case for the retrofitting of winglets to our 767 aircraft. These 3.4 metre high kink tips will save us 1.3 million litres of fuel on each aircraft they're fitted to, and 16,000 tonnes of CO2 annually. And further, in a similar vein, we're currently investing $4.5 million in installing zonal dryers to our jet fleets to reduce the residual water that gets trapped in the insulation blankets within the fuselage, which in turn reduces onboard weight and fuel burn and emissions. I mean, just to put it in context, on a 747, to fly a kilo of weight from Auckland to LA, which is our most intensive long-haul sector, uses half a kilo of fuel. So weight is an enormous opportunity within our industry. Making the right fleet choices is key, but operating the fleet as efficiently as possible is equally important. For example, a simple but significant improvement that we've made is to reduce the volume of potable water that we carry on board the aircraft. Instead of filling the tanks and landing with them half full, we're now filling them to the levels we know we will require during the flight and avoiding the fuel burn of carrying superfluous water. Our focus on reducing fuel burn has been relentless and began back in 2006 with a review by an IATA Go team. And our ops team have been examining all our operating procedures and practices, looking for efficiency and emission reduction opportunities ever since. On the ramp and in the air, we've moved from a relatively conservative approach to fuel management to one that now better reflects conditions on the day of travel. And some of those examples of change include minimising the use of auxiliary power units, refining the fuel uplifted to reflect the actual aircraft payload. In fact, now on a regular basis, our pilots get a graph plotted to show what their discretionary fuel uplift has been relative to all their peers on the same fleet. And that becomes quite a motivating competitive incentive now within our pilot community to minimise the level of discretionary fuel uplift that they authorise for each flight. We're flying slightly slower to optimise fuel consumption. We've changed flap settings and a number of other operational procedures to reduce our fuel burn on ascent and descent. We're minimising the use of engine reverse thrust, and we're taxiing most of our aircraft now with one engine shut down. Working with BMP Fuel in Canada, we've also invested in a fuel efficiency database, Fuel Smart, that provides a statistical basis for a lot of these better fuel management programs. And importantly, right through this whole process, we've worked closely with our pilots to ensure they're an integral part of the strategy and are committed and aligned to our goals and objectives to reduce our fuel burn. I am really thrilled with their commitment and support of our programs, and our pilots are now one of the biggest sources for identifying new ideas and opportunities for reducing our fuel burn and emissions. While on the topic of operational initiatives, I'd like to mention the Aspire 1 flight that we took part in late last year. This picked up on the issue of air traffic management. Aspire stood for the Asia and South Pacific Initiative to Reduce Emissions, and it was a partnership between Air New Zealand and Airways New Zealand, the FAA in the US, and Air Services Australia, and is a great example of how government agencies and the industry can cooperate to innovate and reduce our emissions. It was tagged the perfect flight. It was designed to demonstrate the carbon reduction potential of flying under optimal planning conditions, and we flew a 777-200ER from Auckland to San Francisco with all practical operational constraints removed. First, we took into account all our operational fuel reduction initiatives. Then we took optimal flight paths based on up-to-the-minute weather conditions during the course of the flight. We had priority takeoff and landing clearances, and finally a tailored arrival into San Francisco. The results exceeded our expectations in that we reduced emissions over a typical flight by 11 tonnes of CO2. Just on that one single flight, if you multiply that by the long-haul flights that are occurring on a daily basis around the globe, you get a sense of the potential emission reduction that is available from optimising our air traffic management. So whilst it may sound modest as a single flight, the opportunity is enormous. In December last year, in partnership with Boeing, Rolls-Royce and UOP, we completed the world's first commercial aviation test flight powered by a sustainable second-generation biofuel from Jatropha feedstock. The learnings from this test flight have proved invaluable. However, our ongoing environmental and commercial analysis highlights that the best results for biofuel are derived from feedstock produced and sourced as geographically close to the fuel pumps as possible. And given the growing conditions required for Jatropha, this is likely to mean that in Air New Zealand's case, we'll use alternative feedstocks sourced much closer to New Zealand, and there's some quite exciting initiatives that we're pursuing in our local markets. But for renewable fuels to have a place in aviation, many of us will need to cooperate, including fuel companies who need to step up to the plate if we're to overcome the supply chain issues.